In the heart of the Cold War, while Silicon Valley was being born in the United States, the Soviet Union secretly launched its own technological city. A bold attempt, and a desperate one. Just 37 kilometers from Moscow, behind security walls and military checkpoints, thousands of scientists worked on a single mission: to defeat the West in the race for electronic supremacy. This is Zelenograd, the hidden laboratory where Moscow dreamed of winning the future. A story of ambition, espionage, and the limits of copying genius. The Soviets faced a fundamental problem. They couldn't design microchips advanced enough to compete. The solution was simple and dangerous: steal them. The KGB launched Operation Cold, not an official name, but what Western intelligence agencies later called it. The mission was clear: acquire the latest semiconductor designs from American companies by any means necessary. Soviet agents infiltrated tech conferences in California. They posed as businessmen, academics, even janitors. One famous case involved a KGB operative who spent 3 years working as a consultant for a Silicon Valley firm, photographing circuit designs with a miniature camera hidden in his briefcase. But the most valuable intelligence came from another source: reverse engineering. Soviet agents would purchase American computers through shell companies in neutral countries: Switzerland, Austria, Finland. These machines would be carefully disassembled in Zelenograd laboratories. Every chip was examined under microscopes. Every circuit pathway was mapped. Every design decision was analyzed. It was painstaking work. One microchip could take months to fully understand. But the Soviets had something the West didn't: absolute dedication and unlimited manpower. Of course, this approach had a fatal flaw. The Soviets weren't innovating, they were copying. And in technology, being even 6 months behind means you've already lost the race. But in the 1960s and 70s, Zelenograd scientists didn't care about winning the race. They just wanted to stay in it. In the mid-1970s, Zelenograd produced its crown jewel, the K580, an almost exact copy of the Intel 8080. The West mocked it. Tech magazines called it the Slavic knockoff. American engineers joked about Soviet desperation. But in the USSR, it was a monumental achievement. The Intel 8080, released in 1974, was one of the most important microprocessors ever made. It powered the Altair 8800, the computer that launched the personal computing revolution. It was complex, sophisticated, and represented the cutting edge of Western technology. The K580 team, led by engineer Boris Malin, worked around the clock for 18 months. They didn't have access to Intel's manufacturing secrets. They didn't have the same quality of silicon. Their lithography equipment was generations behind. And yet, they succeeded. The K580 wasn't quite as fast as the 8080. Its manufacturing yield was lower, meaning more defective chips, but it worked. And it worked well enough. Soviet computers began incorporating the K580. Military systems, aerospace programs, industrial automation, all benefited from this chip. For the first time, Zelenograd seemed to be gaining ground. But there was a darker truth hidden beneath this triumph. The K580 was released in 1977, 3 years after the Intel 8080. 3 years might not sound like much, but in the semiconductor industry, it was an eternity. By 1977, Intel had already moved on to the 8085 and was developing the revolutionary 8086. Silicon Valley wasn't standing still, and Zelenograd was running on a treadmill, always sprinting, but never catching up. But Zelenograd was trapped in the web of Soviet bureaucracy. While Silicon Valley rewarded innovation, the USSR punished risk. Every project required approval from multiple ministries. Every design change needed signatures from a dozen officials who knew nothing about electronics. Every deadline was set by politicians, not engineers. The stories from this era are almost darkly comedic, if they weren't so tragic. One engineer recalls spending 6 months developing a new manufacturing technique that could improve chip yield by 15%. His reward? A formal reprimand for deviating from the approved production plan without authorization. Another scientist proposed using a new type of silicon substrate that American companies were experimenting with. The request went through 18 months of committee reviews before being rejected as unnecessary Western influence. Dmitry Volkov, who worked in Zelenograd from 1972 to 1985, later said, "We weren't afraid of technical challenges. We were afraid of our own administrators. You could solve an impossible engineering problem, but if you missed a bureaucratic deadline, your career was over." And it wasn't just careers at stake. Missing production quotas could mean loss of housing assignments. Repeated failures could mean being barred from Moscow. In extreme cases, engineers who were suspected of deliberately sabotaging projects faced investigations by the KGB. Creativity doesn't survive in that environment. Innovation requires the freedom to fail. Zelenograd had brilliant minds, but those minds were shackled. The technological gap became brutally evident on the battlefield. The United States deployed advanced guidance systems, miniaturization, and electronic warfare capabilities that the Soviets simply couldn't match. Consider the Vietnam War. American F-4 Phantom jets carried sophisticated radar jamming equipment, precision-guided munitions, and computerized targeting systems. Soviet-supplied MiG fighters relied on older technology, bulkier, heavier, less reliable. The gap wasn't about pilot skill or aircraft design. It was about the electronics inside. By the 1980s, the disparity was even more pronounced. The U.S. military was deploying systems that seemed like science fiction. Stealth aircraft with radar-absorbent coatings and digital flight controls, cruise missiles that could navigate autonomously, satellites with encrypted communications. The Soviets had equivalents for many of these systems, but their versions were always bigger, always heavier, always less sophisticated. Why? Because microchips matter. A modern fighter jet contains thousands of microprocessors. They control everything from fuel injection to weapons targeting. The more advanced your chips, the more capabilities you can pack into the same space. American jets in the 1980s had computers that were 10 times more powerful than their Soviet counterparts, yet weighed half as much. Zelenograd tried to close this gap. They produced the K-1810 series, meant to compete with American military-grade processors. But by the time it entered production in 1985, the U.S. had already moved 2 generations ahead. The Soviet military knew they were losing the electronic war, but there was nothing Zelenograd could do about it. With the arrival of Perestroika, the budgets were slashed. Many of Zelenograd's laboratories became frozen in time, like technological time capsules of a future that never arrived. Mikhail Gorbachev's reforms in the late 1980s were meant to modernize the Soviet Union. Glasnost, openness, perestroika, restructuring. But for Zelenograd, reform meant something else: abandonment. Military spending was cut. Research budgets were slashed. Projects that had been running for years were suddenly canceled overnight. Engineers arrived at work to find their laboratories locked. Expensive equipment sat unused, gathering dust. Prototypes that represented years of work were shelved indefinitely. Alexei Petrov, a chip designer, remembers, "We were working on a new microprocessor that could have been competitive with Intel's 80386. We were maybe 2 years behind, which for us was actually good. Then, one day in 1988, we were told the project was terminated. No explanation, just terminated. Some of us cried. We had spent 3 years on that chip, and it was just thrown away. The brain drain began almost immediately. As the Soviet Union opened up, talented engineers saw opportunities abroad. Western tech companies, desperate for skilled workers, offered salaries that were unimaginable in the USSR. By 1990, Zelenograd was losing its best minds. Not to Silicon Valley necessarily, though some went there, but to European firms, Asian manufacturers, anywhere that would pay them what they were worth. The Soviet Silicon Valley was dying before the Soviet Union itself collapsed. After the collapse of the Soviet Union, the world discovered something surprising. Zelenograd hadn't been a complete failure. When Western journalists and tech historians finally gained access to Zelenograd's archives in the early 1990s, they expected to find a wasteland of failed experiments and crude copies. What they found instead shocked them. Yes, the Soviets had copied American designs, but they had also innovated in ways the West never knew about. Zelenograd had developed radiation-hardened chips for space applications that were, in some ways, superior to their American equivalents. They had created unique architectures for parallel processing. They had solved manufacturing problems that Silicon Valley hadn't even encountered yet. The problem wasn't lack of ingenuity. It was lack of implementation. Warehouses full of prototypes, filing cabinets stuffed with patent applications that were never filed internationally, production lines that had manufactured a few hundred units of advanced chips and then stopped because there was no funding for mass production. One particularly striking example. In 1984, Zelenograd engineers developed a RISC-based processor architecture that anticipated some of the design principles that would make ARM processors dominant decades later. But without the commercial infrastructure, without the manufacturing capacity, without the ecosystem of software developers and hardware manufacturers, the innovation died in the lab. The USSR had fought a technological war in silence and lost. Not because of lack of talent, but because innovation requires more than just clever engineers. It requires a system that supports them. Today, Zelenograd still exists. It's a technology center in Russia, heir to what the USSR tried to build. Modern Zelenograd is a curious hybrid. Soviet-era apartment blocks stand alongside new office parks. Abandoned semiconductor fabs sit empty, while, a few blocks away, software startups occupy renovated research buildings. The city is home to about 40,000 people. Many are descendants of the original scientists and engineers. There's a pride here, a sense of legacy. Russian tech companies have established operations in Zelenograd. There are clean rooms producing microchips, though not at the scale or sophistication of Taiwan's TSMC or South Korea's Samsung. The Russian government has periodically announced plans to revitalize Zelenograd as a Russian Silicon Valley. Billions of rubles have been invested. Special economic zones have been created. But the fundamental challenges remain. The global semiconductor industry requires massive capital investment, international cooperation, and access to the most advanced manufacturing equipment. Russia, facing sanctions and political isolation, struggles to compete. Zelenograd today is a reminder of what might have been. Walking through the city, you can see the ghost of Soviet ambition, the grand plans, the massive facilities, the dream of technological supremacy. But history reminds us, in the Cold War, the battle for information was as important as the nuclear arms race. Perhaps more important. The USSR dreamed of its own Silicon Valley. It built an entire city to achieve it, recruited the brightest minds, spent billions of rubles, stole secrets from the West. But even a superpower can discover that talent, innovation, and freedom cannot be copied so easily. Silicon Valley succeeded not just because of American technology, but because of an ecosystem, venture capital that rewarded risk, universities that encouraged experimentation, a culture that celebrated failure as learning. The Soviet system offered security, but demanded conformity. It provided resources, but required obedience. It valued results, but punished the very creativity needed to achieve them. Zelenograd was a city of contradictions, brilliant scientists working in a system designed to constrain brilliance. Cutting-edge research happening in an environment that feared cutting-edge thinking. Today, as we hold smartphones more powerful than any computer that existed in the Cold War, as we benefit from chips manufactured with precision that Zelenograd's engineers could only dream of, it's worth remembering this story, not as a tale of Soviet failure, but as a lesson about what innovation truly requires. This is the story of the Silicon Valley that never was. This is the story of Zelenograd.